Hello and welcome back to Life's Biggest Questions. I'm Ron Mackenzie Lafergie. Black holes are some of the most interesting and mysterious objects in the universe. There's quite a bit we know about them and quite a bit that remains unknown. While we may not know everything about them, we do know a fair bit about how they came about. If you're looking for more videos on black holes, check out our video, What is on the Other Side of a Black Hole? Now get ready, it's time to ask the question, how do black holes form? The idea of black holes was first posited by geologist John Mitchell way back in 1783. Referred to as dark stars, these were stars that were so compressed their gravitational pull could cause the escape velocity to exceed the speed of light. They have so much gravity that even light cannot escape their Herculean pull, making them appear dark. Mitchell even suggested a way to determine where these might be by looking for systems that behave as if they have two stars when only one is visible. This was groundbreaking work that surprisingly went forgotten for nearly 2 centuries, since many deemed it to be impossible. However, his writings surfaced once again in the 1970s, and were seen in a new light. Now, it's all fine and dandy to know what they are, but how did these holes form in the first place? How could so much mass be found in such a small area? It is taking immense self-control to avoid making a yo mama joke right now. Well, there are 3 main types of black holes: primordial, stellar, and supermassive black holes. Each type is believed to form in its own way. Primordial black holes are the smallest, with some being just the size of an atom but possessing the mass of a mountain. These are believed to have formed soon after the Big Bang, during the radiation-dominated era. The cosmic inflation of the time allowed for the density contrast required for the formation of a black hole. Stellar black holes, the ones most people are familiar with, are somewhat larger. A stellar black hole, 10 miles in diameter, can possess as much as 20 times more mass than our Sun. These are formed when the center of a massive star collapses onto itself, when it runs out of nuclear fuel and produces a supernova. If the mass of the core is below a certain threshold, this will produce a compact star in the form of a white dwarf, a neutron star, or potentially a Quark Star. If, however, the mass surpasses the Tolman-Oppenheimer-Volkoff limit, it will continue to collapse until a black hole is formed. Finally, supermassive black holes are the largest, with some possessing the mass of billions of suns. These are found at the center of massive galaxies, like the Milky Way. While it's largely agreed that they start smaller and eventually grow to a larger size, it's not completely clear how they start in the first place. Some believe that it begins with a very massive black hole possessing hundreds of solar masses, which then accretes matter from around it. Others believe that a cluster of black holes merges together to form a supermassive black hole, and still others believe them to have formed early in the universe, when large clouds of gas collapsed together. One thing's for sure, these suckers are big. So there you have it. Primordial black holes are small and formed long ago, soon after the Big Bang. Stellar black holes are the result of dying stars with a massive center, and supermassive black holes form by accumulating extra mass. We're just not quite sure how they start. Thank you for watching Life's Biggest Questions. I hope this was interesting and informative, and maybe even inspired you to look into it further on your own. If you like this video, please thumbs up and subscribe to the channel down below. While you're down there, let me know what other videos you'd like to see on the channel. Until next time, I'm Ron Mackenzie Lafergie with Life's Biggest Questions, wishing you the best of luck on your quest for answers.